You're from Penang, right? Island, ah? Oh, which part? Butterworth. Oh, okay. Not so far. Sit train, not so far. Hmm. How frequent you go back? Next week you go back, ah? Mm. I heard from who, ah? You want to further study, is it? So how much allowance enough for you? 1 month. Hmm. Don't know. Uh, if 1 month like 1,000 enough or not? Hmm. Enough, ah? Uh, Actually, I got a grant. I got a grant. Need to sign the agreement first. The company grant, mm, with Intel. So you see, are you interested? I no, I'm doing underfield. Uh, I only talk to you, because actually I have another student, but then last year your senior lah, but then she is working now. January only can come back if can. That's why I ask you if can. The allowances maybe divided between you and her lor. And one person get at least got 1,000 lah. That's why I ask you because this morning only I heard that you want to further. So you think first lah. I if you want, I ask the other student. Uh, so the allowance is divided between two of you because I need the. Uh, I know. Hi. Uh, you in the attendance, yeah? Have you all filled in the course evaluation form? Fill in, yeah, because need to have 37 people. If not the PR will make noise to me. Then I will make noise to you all. I got no choice. I also being forced. So you please help me to fill in. I want to see 37, okay? Maybe while waiting, can you please click the link and fill in? If not, after this, you will sure forgot one. Will sure be forgotten already. So no more tests already, right? Today should be finished all already, right? Next week semester break, right? Only 17, 16. Only 16 people. Aiyo. 16 out of 37. Oh, always these few people log in very early. The rest, yeah. Okay, I think we start now. Have you signed in the attendance? Hmm?
Sign already, sign already.
Signed already, already in hometown, is it? Huh? John,
Yeah, yeah, at hometown.
I know you. The rest, Baroha, are you in your hometown now?
Yes, doctor.
Oh, okay, we start now. Don't wait. Okay. So today's last topic, dye adhesive, dye attached adhesive. You can see my screen, right? Can see, right? Eh? Yes or no?
Yeah, can see, can
Can
see.
see, okay. Dye attached adhesive. Okay. So normally dye attached adhesive is used in wire bond technology. Okay. Why is not in fit chip? Because fit chip, right? When you see fit chip, need the do fish chip need the dye attach or not? No, it's not. Fit chip, where is the fit chip? Mm, ah, this one need the dye attach or not? Dye attach adhesive or not? No need because connection you through the solder bump, right? Then put the underfill, right? So no need don't need. So die attached adhesive is different from underfill, yeah? Different, very different. Okay? Die attached adhesive is to attach the die with the substrate. Okay? Attach the die, the this color. The blue color, okay? So die attached adhesive is not underfill, different, because the formulation is very different. Okay, formulation is very different. So is to attach the die with the substrate lah. So die attached adhesive polymer bonding agent is composite materials. Okay, so it will provide electromechanical junction to create mechanical bond between the silicon or the die with the substrate. Okay, if multiple chip like this one got two, right? So the pink color is the die attached adhesive. Okay, so the function is to lock the die on the substrate so that it will not move lah. So you can do the wire bond. Okay, so die attached adhesive will not use in flip chip technology. Okay, remember y'all. So if the function is as adhesive, okay, or glue, okay, adhesive to attach silicon die to package or silicon die to silicon die. If silicon die to silicon die means like this lah. You have multiple die stacked together. So in between the silicon die and silicon die also can be used. Okay. So if only one die means die to the substrate lah, between the die to package. Okay, so that's the function of die attached adhesive. Let me see. Not we here or not? Nuri not here. Aswani here or not? Aswani also not here. Hiya, only 19. Okay, that adhesive requirement. So the materials, it need high purity. Okay, later we will go through one by one. Quick curing, low stress, package crack resistant during solder reflow soldering. Okay, we see one by one. Okay, the first one, high purity materials mean cannot have any ionic content inside because it's very near to the die, right? So if you have ionic content, then absorb moisture, then it will cause corrosion. So this one will affect your durability to the performance of the devices. Okay, so it must be short curing time because it's to attach the die with the substrate. So the process must be simple and quick. Okay, must be simple and quick because the function is just to attach, right? So curing is within 1 to 2 minutes. Must be done. So it must be cured inline process so that you need to mix the catalyst or accelerator with the hardness ratio to be optimized so that can cure very fast. It's not like underfill and mold compound. Okay, underfill and mold compound you need post cure. This one no need. Perfect one must be done inline curing process. Means during the processing already cured. Okay, so low stress property. So because it's very near to your substrate and also die, right? So DTE mismatch also occur. So you need to have something because if your die and your substrate CTE mismatch will generate the stress, right? Just like underfill. Okay, just like a solder pump, you need underfill, right? Correct or not? So this one is in between the die and the substrate also. So you need something like low stress. Okay, cannot be too hard. If too hard, it cannot. It's also the same. It will absorb the stress and convert it into deformation. But if it is too hard, so it will not do it function well. So you will cause the die crack if it is too hard. So it must have certain modulus. Okay, so that's why we call it as low stress die attached materials. So must be packaged quite resistant. Okay, large, very large. The chip become larger and larger and thinner. Okay, so you will have reliability issue lah. Okay, when you do the soldering process, especially when you're exposed to high temperature, right? Okay, so sometimes they will use die attached film instead of liquid. Instead of liquid, they do use the film. Easier to control. Easier to control. So this is a requirement. So currently the in market, we are using these 3 type of materials. Okay, some people they use gold. Okay, but gold coating you need high temperature. Okay, you need high temperature. Although the CTE mismatch, the gold CTE is very low, right? So so you will what you call it? But you need to if you want to do coating, okay, on the silicon. This one, if you want to use gold, you need to do like coating process like reflow lah. So it's need 400 degrees Celsius. The 400 degrees Celsius, you will cause the CTE mismatch. Okay, then you will generate the high stress to the entire package. And also it's expensive. Okay, so you will cause the economy factor. But one thing is good is CTE, the gold CTE is much lower lah compared to polymer. That is the only good thing lah. Okay, so you can minimize the CTE mismatch. But then this one and this one, okay, it will cause high stress. Okay, so second one is using solder. They use the solder, the metal. Why they use the solder? Because high thermal conductivity. So you see, this one very near to the die and the substrate. So when you on it, this thing, it will generate heat, right? So you need something with very high thermal conductivity so that you can let the heat to be dissipate to the environment. Correct or not? So metal is a very high thermal conductivity materials. And also it cannot absorb moisture. Okay, but then as I say, solder you exposed to the air, to the oxygen, you will form metal oxide. Okay, and if you form metal oxide, so when you do the soldering, you need to use the flux to remove the oxide layer right? So flux, after reacted, you must clean away. So you must have this diffraction process. So it's very costly. And also after wash it, so diffraction, as I say, is warm DI water, right? After you wash it, then the water how? Cannot be straight away. You let go to the drain, right? So you must do something because you have chemical inside. Okay, so it's also an environmental issue lah. Okay, then after that, we consider to use polymer adhesive. Okay, so this polymer adhesive, bad thing is CTE very high. CTE very high, but then processing very easy. Low temperature processing compared to this and this. So it either can be in paste or in film. So in order to overcome this problem, so normally they use metal lah. They fill with silver powder. The epoxy, the filler, they use the filler silver silver filler. Why silver? Because metal very high thermal conductivity, so it can help to dissipate the heat. Okay, and also of course a lower cost process. Okay, so these are the three current materials they are using in the production. Okay, so the process is very simple. You see where to put it. Put the die on top of the substrate to stick, in order to stick it using the die attach adhesive. So of course, after the die, you must the saw die, okay, saw into the rectangular shape, right? So of course you must place the die in the right orientation accurately on the substrate. So normally, how they know about this one? The substrate, they have marking to where to put it. So the robot will recognize, okay? Then the robot will do for you lah. So this die attach adhesive, as I say, it can be firm, quick, okay? It can be eutectic solder or gold preform, anything, or resin filled with silver powder, okay, also is possible. So a bonding medium means the die attach adhesive. First apply on the substrate, then die attach paddle is like a pocket to put your die, okay? So you will put the die attach adhesive inside the die attach paddle, the pocket, and then only place the die. Then after place, you need to let it like give some pressure, right? So normally we to give some pressure so that the air will escape lah, so it will stick properly before curing. So wrapping is applied lah, okay? So to spread the adhesive evenly and to improve the bonding, okay? So after that, cure, okay? So medium in between to enable the next wire bond. If you never stick the die permanently on the substrate, you cannot perform the wire bond process. This thing will move. This die will move. Then you cannot process with your wire bond processor. Okay? Okay, so first you must saw your die. Saw your die first. Okay? Then the substrate. Okay? This is example of dual package. Stack together, package on package. Okay, two die stacked together. Okay, first this is the green color is the substrate. So of course it had the pocket lah. Okay, where to put the die. So you will dispense. Okay, because it's liquid. Okay, you dispense to the your die attached adhesive on the substrate. Then only the wafer, the robot will place the wafer there. Okay, then you cure. Okay, let it have a permanent bonding. After that, when you want to put the second die, you put the die attached adhesive on top of this the bottom die lah. Then after that, you put your upper die, then cure. Okay, simple process. Okay, means dispense, place, then cure. Very simple process. Okay, so when you do this process, okay, you see you have the die, then you have the substrate. Okay, So you want to stick this one on top, right? Then you use adhesive, right? You use the adhesive, right? Okay. The adhesive is the green color lah. Okay, you do the adhesive, right? Okay. So now, this one thicker. Okay. So now, every time when you do this one, how to control so that it won't like sometimes you have more. If you have more, it will leak outside lah. Correct or not? If not enough, then incomplete lah. Correct or not? So how they control this? How they control this? They control the bond line thickness. Means how thick is it? How thick is it? Okay, so control by the weight lah. Okay, will control by the weight. Okay, other than weight, also viscosity lah. The viscosity cannot be too high. If not, it cannot like sit over here, right? It will just flow outside, right? Viscosity also need to control. So the weight they will control so that it will have like almost uniform thickness. Okay, almost uniform thickness. Where's the thickness? Here lah. Okay, this is the thickness. So weight control also need to control because polymer very easy tends to absorb moisture. So you need to control the moisture level so that you won't have void problem. So during processing, they will heat up. Okay, they will heat up so that the die attached material will not absorb the moisture. Okay, so of course you cannot have contamination. Okay, die contamination or accidentally the robot put the adhesive on top of this die. Oh, reject. Okay, the one is called die contamination. Okay, or incomplete way out means not enough. Material not enough. Okay, or the material is like I say, or use too high already will cause the die crack lah. Or your robot accidentally hit on your die also will cause die crack. So die placement also important. Make sure your die is placing exactly this pocket the attached pedal, the pocket inside the pocket. Okay, cannot here. So equipment also must be stable and capable so that you can reduce your production time and production cost. Okay, so when we do this one, the effect will sometimes we will have die crack Okay, die crack you have many types. You can have vertical, horizontal, or corner. Okay, vertical, horizontal, or corner. So this one all must be avoided Okay, you see this one? You will have die crack. Why cannot have die crack? Because the crack will propagate. If it propagate, then you will cause the whole thing to be broken already. Okay, so this is another example. So they use this CSAM to see. Okay, wherever they see the white spot so they suspect something happened. So this one they cross up to actually have the die crack. Okay. Okay, so when we talk about adhesive, what are the criteria to determine whether it is good or not? Like you do testing, right? For this one, we have 3 types. Okay, the first one I explained to you is called adhesive failure. Okay, adhesive failure is a failure of the adhesive to stick or bond with the materials. Okay, cannot understand, right? Okay. So you see this is the die. This is a substrate. Okay, so the white color one is your adhesive. Okay. In what condition we call this one as adhesive failure? Where when you do the testing, the thing break over here. Or break over here. Okay? So this one, because the adhesive, it cannot form very good bonding with the dye or the substrate. So when they do testing, they pull it, it will fail at this point. So this is the failure on adhesive. So we call it as adhesive failure. Okay? Okay, this is the first one. So the second one, cohesive failure. Cohesive failure is structural failure of the adhesive. Adhesive remain on both substrate surface, but the two items separated. This one is whereby, where does it break? Here, at the center. This one means what? The adhesive can adhere to form the good bonding with your substrate and also with your dye. Okay, with your substrate and also with your dye. So good adhesion here, so it won't break over here. It break at the center. Means the bonding between your adherent with your substrate surface is good lah. Okay, so this one is what we call adhesive failure. Cohesive failure. Sorry, cohesive failure. Okay, it will break at the center. Okay, how about substrate failure? Okay, substrate failure is the failure occur on the substrate. One of the substrate or both of the substrate. Okay, that is what we call substrate failure. So it is not a failure of the adhesive. In this case, adhesive remain intact and is still bonded in one substrate and the remaining of the other. Okay, so in this case, if we use the same example, okay, if we use the same example, another one, okay. So if substrate failure is substrate failure, then it will break at the substrate. Either at the dye or at the substrate. This thing still remain very good. Okay, so it means what? This adhesive play the function very well. Okay, play the function very well. So the arrow no more here, arrow no more here. Okay, so means adhesive play the function very well. Okay, so this is called substrate failure. What do you think? Which one is the best? Which one is the best? Adhesive failure, cohesive failure, or substrate failure? Which one is the best? This one is the best result you got. Which one? Which one? Senyap saja. So quiet, sleeping already. Cohesive, Just say cohesive. Nisa baru join. Baru 23 orang. So the best, of course, the structure, whole thing never fail. This thing all never fail. But fail at the substrate means very, very strong. It's very strong. Cannot play with it. It's very strong. So the best will be this one, substrate failure. Although the substrate is failed, but the adhesive is still remain unchanged. The structure is still very strong. It is stronger than your substrate. I mean, this thing, the strength is stronger than your substrate. Your substrate fail first. So the best will be substrate failure. Okay? Okay, when we do testing, so when we do testing, this is what testing. This is what testing. This is what testing. Somebody? What testing? It's so quiet today. Why so quiet today? Isaac? Isaac? Isaac apa testing ni Isaac? Isaac? Or anyone? What testing is this? Cannot be known. Huh? What testing is this? Huh? Jeff? Instron Instron is the machine. Hello, Instron is the machine. I want the testing name. Yes, it's using Instron. What's the testing name? Very close already. Don't give up. Hey, not impact You see the strength. Up and down.
Tensile.
Tensile. Yeah? Yes, tensile. Okay. Hanya 3 orang yang mau jawab. Hanya Pak Roha, Chaimi dan Jeff. Hiraukan saya, yang lain tak mau hiraukan saya. So you see the stress pull up and down. So it is tensile lah. So the sample, the purple color is the adhesive. Okay, the gray thing is the substrate lah. So they want to check whether the adhesive strength is good or not. So pull it. If you see after pull, you see one side, this one, gilat, apa pun tak ada. Means adhesive not doing the work well. Adhesive never form bonding on this substrate. So it's adhesive failure. Okay, the second one. Same sample, same dimension. After pull, you see, both sides also see, you can see that's adhesive, means the bonding to the substrate is very good. Okay, the bonding on the substrate is very good. Actually, this one is good also. Okay, better than adhesive barrier. At least this one got bonding. Okay, but in between is not good, so it's called cohesive barrier. Okay, this one is just like when you buy something, right? Then you have the price tag. Okay, price tag. The stick on your things, right? So sometimes when you want to use like your water bottle, you want to use, so you remove the price tag lah. Cantik kan? I want to remove one. Sometimes some of the sticker very easy to remove, but sometimes when you remove it, it will leave on the bottle, right? Very difficult to remove, right? So the adhesive is actually very good lah. Okay, the one very easy to remove one adhesive, the bonding is not very good. But then that one is what we prefer, right? So once again, see what you want to use. If price tag, I prefer this one. I prefer this one because easier to remove, right? When I want to use. If not, I need to use what hot water lah, or soap lah, alcohol lah to remove it, right? Okay. Of course, if for die attach, for die attach cannot lah. Cannot have adhesive barrier, cannot. Okay? Cannot. Okay? So we hope for cohesive or substrate lah, at least. Substrate is the best lah, because the structure, you see, actually it's not only tensile, but you can do fracture also. So depending on what do you want. Okay? What do you want? Okay. If fracturer, then 3-point bend 3 point. So you bending here. Okay. Normally, if 3-point bend, the sample will be Like the day I draw, the sample will be same I mentioned normally normally, unless you have special requirement. Okay, so substrate, center adhesive, so 3-point pen, okay, texture. They do it like this, okay. This is texture, okay. So substrate failure is where when you break on the substrate, okay, you break on the substrate. But adhesive still very strong, the adhesive still there, okay. The substrate break first, so this is the substrate failure, okay. So this is the testing that you can do for adhesive. Actually, for adhesive, we can do many testing, macam-macam. Okay. So sometimes they put it like this. So it's depending what do you want, what is your application, and what is the mode you want to use. Okay. Sometimes people pull like this. Sometimes people pull like this. Okay. So if structural failure means substrate failure lah. Okay. So this is adhesive adhesive, and if the surface still okay, this is cohesive. Okay, so another one thing to relate with your wetting properties, how to have a good adhesive system without failure is related to your contact angle. Okay, sometimes you can see contact angle between the two materials. You already can estimate whether they will form good adhesion or not. Okay, whether they can form good adhesion or not. Okay, first thing I want to tell you is you need to be careful. Okay, this one many people make mistake. Many people make mistake. Okay, especially with the angle. Contact angle, you must measure the angle, right? Don't ask me how to measure this angle. This one, your secondary school already, you learn before. SPM, you learn before. I think metric, you learn before. Diploma, I don't know, but STP, you learn also. Correct or not? Don't ask me how to measure this one. Okay, so where will be the angle? Okay, so you see, if this liquid is oil, then we have water. Okay, so the upper one, if it's oil, this one is the environment. You just ignore it. Maybe I just hide it somewhere. You ignore this oil, assume it's environment. Okay, so you put the substrate with the water. Okay, so you want to estimate this water and this substrate, whether it can form good adhesion or not. So for your die attached adhesive, where to put your material? Here lah. This one you put your die attached adhesive. This one either you put your substrate if you want to check on substrate, or this one can be your silicone die if you want to check on silicone die. Okay, so you want to check, you want to see whether this die attached material can form good bonding with your substrate or not. Okay, so you drop one drop on this substrate. Then you measure the angle lah. Okay, so if in this point, so area is here, must be here. Okay, so where will be the angle? So remember, it's not the outside one. Many people take this one. Last time I marked a PhD student. She sat here, that is a major mistake. Wrong already, wrong. So you must remember is inside. You want to measure the liquid between the liquid and the substrate. So you must measure inside, not outside. It's inside. So the angle must be inside. Okay? Okay, for example, this one, we draw a line here. It's inside, not outside. Because why? The lower the contact angle, the better is the adhesion properties. The lower the contact angle, the better is the wetting properties. Okay, so compare this one and this one. What do you think? A and B. Which one will have better adhesion and better wetting? Which one? A,
B.
B, right? By seeing already know. This one, the mouth. Refuse. This one, good, better. So smaller contact angle. Okay? So you cannot measure here lah. Measure here means wrong already. How to explain? I also don't know how to explain. Because higher contact angle, right? So the good adhesion, your contact angle must be less than 90 lah. Okay? If more than 90, definitely. This die-attached adhesive, of course, you cannot form good adhesion or good bonding with your substrate. This is how they estimate using contact angle. Okay, using contact angle. Okay, using contact angle. So, neutral means 90 degree. There's a case neutral means 90 degree. Okay, so the best one, the best one, 0. See, sangat suka pada substrate ini, sangat suka. No refuse means what? Surface tension? No surface tension. Like very much. Two of these materials can match very well. This one's surface tension must be very, very high. Worst one will be this one. Then second worst, this one. This one the best. Second best. Seldom can get this lah. Seldom. Nobody like this. Less than 90. Or less than 30. Less than 10 consider very good already. This one very seldom can get. If die attach adhesive with the substrate. Okay, can understand? So today you learn about contact angle, right? Like just now, I mentioned about surface tension. I think this is something new to you also, right? So that when you go out, you don't know anything lah. So people mention contact angle, surface tension, then you know. Surface tension, it has the formula. It's very complicated. This one is just for your understanding only. You will not come out in exam. Okay? I know you all see this complicated mathematic equation already cannot already. But I need to explain to you also so that when you go out, don't like everything don't know. Cannot be. Okay, so let's say you have a liquid here and you have a solid here. So the environment is a gas, right? Okay. Actually, we have 3 types of surface tension. One is between your solid and your gas, SG. Surface tension between your solid and your gas. Second thing is surface tension between your liquid and your solid. The third one will be this one. The surface tension between liquid and your gas. So you have 3 types of surface tension. Okay, if you want to have good adhesive, okay, this is the equation. This is the equation. The L and G, okay, liquid and surface tension, cos theta, this angle equals to surface tension of solid between solid and gas minus the solid and liquid. This is the formula. Okay, so make sure it's low enough. Someone message, right? Okay, B. Alright. Aizat. Ada dekat situ ya. Teman buka mic. Okay, so if surface tension between gas and solid is bigger than surface tension between solid and liquid, your cos theta will be more than your cos theta more than 0 means your theta will be less than 90 lah. Okay, so less than 90 means good, still good wetting, you know. Okay, so if you see your surface tension between the gas and your solid and the gas, this surface tension between this one is lower than surface tension between your solid and liquid, means definitely the contact angle will be bigger. Then this one will have poor wetting. Okay, so that's why when you read the journal, sometimes they will mention surface tension between substrate and the gas, or surface tension between the attached adhesive with the substrate. So that's the usage. Okay, that's the usage. So it's interrelated, you know. If your contact angle is low, okay, contact angle is low, then your surface tension will be lower. Okay, surface tension between your liquid and your solid will must be low, so that you can have good adhesion, good wetting. If the surface tension between your liquid and your solid is very, very high, means they will refuse to contact with each other. So the contact angle will become very high like this. Like this. Okay, this is whereby the surface tension between the substrate and the liquid is very high. Okay, if very high means definitely will be more than 90, so the wetting will be bad lah. Okay, so that is the interrelationship between contact angle and the surface tension. So today you learn something, okay, today you learn something. Okay, understand or not this one? Okay, understand or not? Can follow or not? Still can follow or not? Who already cannot follow? Understood, good. Okay, Muiz sudah masuk. Haswani ada tak? Haswani tak ada. Haswani tak ada kan? Haswani ini she is not slow learner. She is not slow learner, but I cannot understand why always the test and the final exam she doesn't want to study one. Why? Why? The slow learner, if you take the effect also, you can get improvement. This one is not slow learner, but how come the grade always down I want to get the P1 again, Haswani? Beritahu dia. Apa terjadi? Okay, target for the attached performance. Okay, so target that we want. Okay, so now we have elastic modulus. Okay, then you will have adhesion. Of course, must have high adhesion, right? You must have high adhesion, right? As I say, modulus cannot be too high. Modulus, if modulus too high, how? If modulus is too high, it will cause the die crack. It's too hard already, so you cannot help to absorb the stress, the thermal stress. Then, although your adhesion is very good, but your modulus is very high. Okay, so it's not good lah. Okay, it's not good. If your modulus is too low, then your adhesion is low. So it's not it's not good, right? Although you can absorb the stress, but then delamination, so it will cause defects. So the perfect one target will be this one. Good adhesion, high adhesion strength, high but low modulus. Cannot be too hard lah. Too hard, you can cause die crack lah. The stress no place to go, go to the die or go to the substrate. The substrate is harder than the die. As I say, the die is very, very thin. It's thinner than your substrate. The substrate, how many layer, you know? Then the die is weaker than your substrate, of course. It's very fragile. Okay, so you will have die crack. So the blend already broken. How to function? Okay, so for higher adhesion, what we can do? This one, for those coming today, you got bonus. Okay. So higher adhesion means what? Better. Some people will say, where's the text? Higher adhesion means what? Sometimes you say better contact angle. What is better contact angle? What's the meaning of better contact angle? Lower contact angle lah. Contact angle need to be lower, right? So if contact angle is lower, means what? Adhesion is good or bad? Adhesion is good or bad? Adhesion is good or bad? Good lah. Cannot see, This one go away. More there. Okay. So adhesion is good lah, right? Okay, I want to ask you, if in this case, as a materials polymer engineering student, if I will ask you to set ingredients, if you want to have a good adhesion, lower contact angle, what you should add? What you should add? In your formulation, what you should have? What you should have? Good adhesion. You study composite also, right? Good interfacial interaction, good adhesion. Good adhesion you tak boleh tangkap. Good interfacial bonding. Kalau masih tak boleh, macam mana ni? So what you should add? Cepat-cepat jawab, cepat-cepat tutup kedai. Hey, what you should add in your formulation? Of course formulation must have metric, must have filler. Correct or not? The most important thing is what? Adhesion. This is not polymer blend, no polymer blend. Filler and metric. Polymer blend, yes. To polymer, you add compatibilizer, yes. Add coupling agent. If I want to say, yes, coupling agent. Okay. What is coupling agent? Siapa tak tahu coupling agent dekat sini? What is coupling agent? Coupling agent is adhesion promoter. Okay. Kalau orang mention adhesion promoter, coupling agent lah. Coupling agent ada banyak jenis. Okay. If it's polymer blend, then polymer blend is you using two polymer. If polymer blend, you want to improve the adhesion, want to improve the interfacial bonding, yes, you use compatibilizer. If you the system only have matrix and filler only, not the polymer brand system, then normally you use coupling agent lah. Faham ke? Understand? Okay? Tiap-tiap kali you hadir, you ada bonus. Bila saya cakap bonus, you understand what I mean. Okay? Okay. Understand or not? Understand? I delete lah. I delete oh. Bagi dia balik. Mana boleh tak ada title. Okay? Okay ah? Okay. This one also, this one to tell you. Normally, we talk about adhesion, right? Actually, we have like physical effect and chemical effect. Okay? So sometimes when you read through the journal, they will say, always mention about this word. Sometimes in FYP, this is also I see. Interlocking. Interlocking. Okay. Always see interlocking. Have you heard about this word? Interlocking. Normally interlocking means what? They have physical contact only. It's interlocking. If your system have chemical bonding is chemical bonding lah. Bukan interlocking. Okay, interlocking is whereby the two faces, the surface must be rough. When the surface is rough, then it can interlock with each other. Interlocking. Okay, so this is physical contact. Physical contact. If the surface is smooth, then also you can form the bonding. Maybe you can use adhesion promoter to form covalent or hydrogen bonding. Then this one is called chemical bonding. Okay, so when you use coupling agent, I don't want to see interlocking lah. When you use coupling agent, you only interlocking. What for you use coupling agent? Coupling agent, we want chemical bonding. You use coupling agent means I want chemical bonding. I want interlocking. Okay, interlocking is physical contact only. Okay, so you have two types. One is physical, one is chemical. Okay, one is physical and one is chemical. Physical called anchor effect, must have certain level of roughness. Must have rough. If smooth, cannot have physical contact, cannot have interlocking. Okay, cannot. If your surface must be smooth, you must do the chemical bonding. Okay, you must do the chemical bonding. Okay. Okay, understand or not? Can understand? Can? Then we move to last slide. Can understand or not? Yes. I saw the thumb up. Okay, last slide. This one, die attached crack. Okay, so this is how they detect it. So from top, you see there's a, this one it must use X-ray. Only you can see. So actually, this is the two dies stacked together. Adhesive is here. This is top die, this is bottom die. They have another spacer here. And this is the adhesive. So you see the bonding is not good. Then you will have die attached crack. If this crack can propagate, it can propagate either to the top or to the bottom. Okay, so this is something we don't want. Okay, you see, separation, delamination. This is the one. Okay, so this is my last slide. I think yes. So any question before we end? Any questions? Any question to ask me? Any questions? Huh? Any question? Wait. Can you hear me?
Yeah.
Then why just now just keep quiet like that? So any question before we end? Don't worry.
No, I think.
We not. We not. Sampaikan salam kepada Haswani dengan Nasri. Nasri juga keluar ramai datang kelas tau. Apa lagi ya? Yang geng-geng dia. Ramai datang hari ni. Saya tak tahu kenapa. Wait. Wait lah. Siapa yang masuk lambat? Sekarang, sekejap lah. Saya tunjuk. I show you the attention. Please sign in now. For those hasn't signed in yet. And also don't forget to fill in the course evaluation form, okay? Okay. Siapa belum isi attendance lagi? Tolong isi sekarang. Ada orang tak isi lagi tak? Nisa sudah isi, Nisa. Nisa? Nisa?
Dah, doktor.
Semua sudah? Sudah, saya off it. Okay? So, next week will be your semester break. Those who hasn't finished your FYP, just need to finish it. Okay? So, Nisa sudah cabut. So, happy holiday for next week. So, the next week after holiday, Dr. Zina will take over the class. Later, I will invite her into the group. Okay? So, remember, I will check the course attendance form, evaluation form. Please fill in ya. Minta tolong ya. Kalau tak PR datang bising saya pergi bising you lah. Okay? Thank you, Mutri. Okay? Okay, so that's all for today. Okay? Anything you have problem with your FYP, you can PM me, come to see me. Okay? Don't shy. Okay? Come to see me, talk to me. I want everyone to get a good grade lah. Okay or not? Tulis betul-betul ya. Chapter 4 tulis betul-betul. Can start writing chapter 4 already Don't wait
On the way.
Good. Start writing now so that you will have good chapter 4. Chapter 4, major marks come from chapter 4. You will have good impression if you have good writing. Okay or not? And also the format, as I say, format is also important. Some of you in semester 1, you know, right? Why can I get A? Because of the format. Already mentioned to you, format, very important. Not the comment is not from me. From previously, the EAC did it like this. So I need to sampaikan message, okay? Because the EAC is coming. Most likely they will check on your thesis. So please do it well, okay? Okay, anything you still can PM me, okay? Okay, happy holiday. Bye.